details and much more. With Hermine heading up the east coast of the U.S., we take a closer look at the science and frequency of these hurricanes. William Brangham is back with more.
Hurricane Hermine is the first major hurricane to hit the United States in 10 years. Sandy, which did tremendous damage in 2012, wasn't a hurricane when it came ashore. So why such a long period of time since the last major hurricane? To help answer that, I'm joined by Sean Sublette. He's a meteorologist with the research group Climate Central. So Sean, just take on this question. Not that anyone is really complaining about this, but why have we gone 10 years since the last major storm hit this U.S.?
We really have been lucky at this point. Weather patterns change from year to year, and the Atlantic basin has been active over the past decade or so, but the steering winds at any given time have largely directed the major hurricanes away from the continental United States. Now, to remember, a major hurricane, by definition, is a Category 3 or greater storm, a 3, 4, or 5. Hermine was a Category 1 storm, and like Sandy, certainly doing a lot of flood damage, but did not really attain what we technically define as a major hurricane.
One of the things I know is that a lot of the climate models initially had predicted that if the temperature globally goes up, which it has, and oceans had got warmer, which they also have, that we would see more of these storms and a greater frequency of this storm. So are these models somehow contradicted by this last decade?
Not necessarily. I think what most of them have begun to indicate, really, if you go back to the most recent IPCC analysis or the consolidation of the research, is that they're not necessarily going to become more frequent, but there is going to be the tendency, or at least likelihood, that the ones that do form are going to have more intense rain and very likely stronger winds, so that the ones that do manage to develop will likely be stronger. And the fact that sea level has continued to rise as a lot of the polar regions have seen the glacial ice melt, that will compound any kind of storm surge flooding that comes from hurricanes.
So this last 10 years and the models that you're describing, they don't really help us understand what the next 10 years could look like for the U.S.
Yeah, for the very short term, there is not an awful lot of skill with those particular batches of climate models. The shorter term is really kind of that area that most of the work needs to be done. What we do look for the longer term trends when we think about climate change, as climate is a much longer term phenomenon on the order of decades to a century versus so much several years to a decade.
So let's go back to Hermine, which is now threatening the Atlantic seaboard. We've got something like 30 million people up and down the coast that might be looking at some glimpse of this storm. What are we likely to see this weekend and into next week?
What we're really concerned about going forward into tomorrow, as the center of storm goes up the southeastern coast, affects Hampton Roads, Virginia, and then, as we alluded to earlier on in the broadcast, going off the New Jersey or Delmarva Peninsula and likely just stalling for 2 or 3 days. And it may attain hurricane status once again, but really the biggest story is going to be the tremendous coastal flooding, as if this system just hangs off the New Jersey or Delmarva Peninsulas and spins for 2 or 3 days, you'll have a broad area of winds coming onshore that will likely lead to some serious coastal flooding.
So why is the stalling important? I mean, I take it you're saying we would prefer it to just rush through more quickly?
Absolutely. I mean, most of the time, once these systems push northward, they begin to accelerate back out to sea. The steering winds, however, with this particular system look like they're going to set up so that it's going to stall once it clears off the Virginia Capes and just offshore, only about 100 miles or so. So if it just sits and spins in that counterclockwise direction, you have a continuous fetch of water onto shore from those strong northeasterly winds, and that's what's going to pile up the water along the coast.
All right, Sean Sublette from Climate Central, thanks very much.
Thank you.